Hello, everyone. I'm really glad to be here. I've been enjoying all the talks while I was still trying to tweak my presentations because I wasn't quite prepared, but it was so engaging. I just kept going to the talk and abandoning my talk, so I'm not sure how well my talk will go. But I wanted to actually start with how many of you in the room consider yourself a data scientist? I do some data analytics of some sorts. So as I thought, not too many. I think throughout the day, privacy was obviously a main theme. Much of it is about the fact that lots of data companies and maybe data scientists like myself, that's what I was asking, are grabbing your personal data without your permission and you're upset. I totally agree. I don't use a lot of smartphone for that reason myself, so I would agree with that. I am trying to present work as a data scientist, and privacy as a definition for me is a little bit different than up to now. Up to now, it was all about, the user's privacy that we want to respect. I'm going to turn it around and say, as a data scientist, I have to do my job. That means I need that data. I need to see that data. I would like to respect your privacy, and I am trying to do privacy research in a way that, how do I do my job while still not guaranteeing anything, but at least enhancing as much as possible the privacy during my task? So it's a very different perspective on privacy. And this particular research, if you were to put it into a box, is a Hye research project with research design, experimental design. I'm not a Hye researcher. My colleague Eric at U of F in the Indie Lab, he's the, let's say, the researcher behind this research. I am a researcher. I'm just a data science researcher. And so I thought that background would help you. So I'm going to start by saying there are many good reasons to have legitimate access to what we call personally identifiable information. For those of you who are data scientists in the room, we all know that when you're doing data science, data wrangling is up to 80% of my activity. It's not the fancy algorithm, whatever, it's the let me get the data cleaned up and standardized and figured out how to measure things so that I can actually use it. And I have no idea how I'm going to get there, but I have junk. Somehow I'm going to turn that into information, and somehow I'm going to do some modeling. And in that process, please don't ask me to close my eyes, because I'm not sure how I would do that. So even if you're doing the more fancy machine learning stuff, how do you do that? Well, even if you're automating it, I have to tune my parameters. Most of you are computer science trained. You know about the fact that you can have fancy algorithms, but if the parameters aren't tuned, they're useless, right? I have to build training data sets that come from the real data. So there are very good reasons why I need access to that PII that everybody is concerned about. And yes, that's a problem when it's really sensitive information like HIV status. Along with your names and social security numbers. Nobody wants me to have it. But I would like to suggest that, personally, there are not legitimate access without explicit permission, much of what was discussed at this conference, versus legitimate access without informed consent when you're talking about the public good, like doing research on cancer and HIV. And informed consent has other issues, but one of the main issues related to research is that it results in biased data. So when I'm doing and trying to figure out clinical care for someone, I'm really, really sorry, but I don't want to do informed consent on a database I have, right? I don't want the bias in there. So I'm not suggesting that we should all just let everybody do whatever they want with that data. I'm just suggesting please entertain the idea. There are very good, valid reasons to have legitimate access without informed consent. And that is exactly why I am interested in providing and designing privacy-enhanced systems so I can do these activities. That's the idea. There have been partial solutions. People have talked about privacy-preserving data analytics of different kind of algorithms, and they're encryption-based. They restrict access. They say, humans don't need to be involved. Algorithms can figure it all out, so why do you need to see the data? There are a lot of research is on synthetic data. Let me give you a data set that's not real about me. Well, guess what data science is all about? It's about the fact that you didn't know the signal when you went in and you found it. Building a synthetic data means you are preserving signals that you already know is in there. That's called training and teaching in the classroom. That's not called research. So all that research about privacy preserving using synthetic data, to me, this is good research. It should be done. This is what you should do when you're doing training, but it's not real data science research in the health realm. By the way, I'm a tenured faculty in public health with a PhD in computer science and data mining. That's where the background of all this is. So the truth of the matter is I'm really, really sorry, but I just don't know how to do magic when every single day, whatever I had access to last year, I don't have. And it's really, really becoming a problem for me. So I've been doing this for about 20 years. When I first started out, nobody cared about security and privacy. They gave me everything, like 50,000 social security numbers, go do, and I did. Every year, I keep losing things. I'm like, are you sure you don't want me to use this? Because my results could be a lot better if I had it, but they keep taking it away. And so that's just something to think about. And the idea here is, here's another bit. I think this part, lots of people here know. This is the background theoretical literature on the most cutting edge privacy, differential privacy. Everybody's heard of it. Well, what they say, so the theory part of this, what they say is, I'm sorry, no free lunch. You cannot get utility from the data set without some risk in privacy. There is no one size fits all. And there is no way to benefit from data when you don't take some privacy risks. So the idea is, would you like me to run a clinical trial to figure out how to treat you better, or can I just use your data? Or maybe we don't need to know anything. I don't know. What do we have, right? So that's sort of the things that you have to think about. So that's that balancing. But we have hope, or I think we have hope. So the 4 things that I think about when I'm doing privacy by design, the first is, so exactly how much data do I need to really look at when I'm in that garbage dump? Really, really, really not very much, right? If I'm talking about my 10,000, 100,000, 20,000 data set, I am not looking at every single row, every single cell. I am looking at 1,000 of them, maybe 2,000 of them, maybe percentage-wise, very, 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 very little, right? So if you were to just take a step back and you say, well, how about we have an agreement? You let me go in there and look at whatever cells I want to look at within the limit of 1%. Then I can be a happy data scientist, because I can usually do my job. The problem is nobody talks like that. Nobody thinks like that. Nobody gives me a world like that. So that's just one. If you have that insight as a data scientist, I feel like we can design very good privacy-enhanced systems to really get benefit out of data. That's one. And then the other things are what really matters. So who knows where to look? Is it let's say, the algorithm developer, software developer, security scientist who's going to give me an algorithm that I'm going to do my magic with my eyes closed? I don't think so, right? When do you know what you need to look at? So you ask me, I'm a data scientist. Can I tell you when I'm writing my research plan and submitting it to the IRB exactly where I'm going to look at? I am sorry. No, I can't. I have to be in the data to figure out what I have to look at. So I can't tell you ahead of time. That's the problem. Because I can't tell you ahead of time, I'm like all the data scientists. Give me anything you got, anything I can get my hands on. And yes, I'm sorry, it's HIV data. That's the problem. So keep that in mind. And then finally, while I'm in there looking at your HIV status, if the patient comes along and goes, what are you doing in my data? I can look up, and I can look him in the eye, and I can tell you what I'm doing in there and why I'm in there. That's the important part. That's the privacy part. You have to think about the purpose, and you have to think about, is that legitimate, and are you doing OK in there? If you keep these things in mind, I feel like we have hope in designing a privacy-enhanced system that we can actually do and get benefit from data while still protecting a lot of the privacy. So the idea here is I worked with a Hye researcher to say, what are key design elements that you would build into such a system? And here are 4 things I put in here. First of all, we have to really move away from all or nothing. So I told you about the stuff I do. Most people, when they first hear about this, they just look at me funny, because they've never heard of this access to all social security numbers for everybody in your state. Well, if you have a state contract, then that's your job. That's what you get, right? So what happens is either you're one of the privileged club members, and you get access to everything. Nobody asks what you're doing in there. Or you don't get access to anything, and then it's a nightmare. Right? So we have to really move away from the all or nothing and find ways to do partial access. Second, you can't ask me what I need at the beginning. You have to let me go in to figure it out. So this is about just-in-time access and decisions about what I'm going to look at. I think I've shared just-in-time is a key characteristic of what gives benefits to computer science technology. If you can delay decisions until you know, you can make a lot better decision. And this is about just-in-time decision to look at what I'm looking at, right? The third part, it's about monitoring access. It's not about guaranteeing or limiting access. It's about you recording every single thing I'm doing. And the ability to come ask, what were you doing in there with that cell? Right? So it's about monitoring access, which is much like the surveillance cameras in our physical security systems, which, depending on who you talk to, may be the most important part of a security system. Is it those 5-time locks with a biosensor, or is it the surveillance camera that keeps the people out? What's discouraging people from doing bad things in places you shouldn't be doing? I think it's the surveillance camera. That has nothing to do with encryption. It's actually, in this computer system, a lot more about privacy by design. So that was I'm sorry my background is a little big, but the actual problem I'm working on for this particular, my first attempt at trying to design a privacy-enhanced system was in the problem of record linkage. It's very simple. I have two data sets. I would like to know which row is which. Because guess what? My job is to count how many ED visits everybody had in a city. Why? Because your tax dollars rely on this. When you do reimbursements on Medicaid, the hospitals get paid at a different rate depending on how many times you have revisits. If you have good data and you can put them all together, you can have accurate revisit rates, and that would determine what hospitals get paid. Versus if you have bad data, I'm sorry, I can't see anything. I can tell you how many people came back to my hospital. I have no idea if they actually went to another ED. That is the current state. That's a very sad state given what we can do with data. But that's why I'm working on record linkage, and that is why I am working with the most sensitive data. I'm working with your social security numbers and names. That's the problem I'm working on. And I have two goals, right? My privacy goal is to limit disclosure of your names and social security numbers as much as possible. And my utility goal, but without reducing my ability to do a job. It's the human's effectiveness in doing your data science job. So here's the real question. Can I find the sweet spot between accessing PII for legitimate use while also providing maximum protection for privacy by using a privacy by design approach? And the spoiler is yes. At least in this case, we've done some studies and evaluations, and we could do it. So if you look at the 3 bars, that at the very end is full access. This is the current status quo. You go through a lot of hoops, but you get in the club and you get access to everything, and nobody cares what you're doing in there. That's considered the current status quo, very little protection. The second one is a static design. This is work I presented last year. It is based on a static design. And what we can show is that we can do the same work with 30% of disclosure. So that's a lot of protection. This year, I took all the static stuff that I did and put it together to do a dynamic design. And now I'm down to 7.8%. So by looking at only 7.8% of the data, I can make the same quality data science decisions as I can with 100% of results. So this means I can maintain my utility with a lot more protection. And this is what I'm trying to present. I'm going to look at my time, because I didn't think 17 minutes was going to be very much. So basically, you can find much of the results in our paper. But what we did was we actually studied different ways of putting this together. And this is the interface I wanted to show you. So you have 2 rows of identifying information, and your job is to figure out if this is the same person or not. So that's section 1 is the minimum disclosure, if you see in red. The second part is the actual accountability by quantifying the risk. So there's a meter that goes on top that tells you how much has been seen, which is measuring the risk that's involved. And then the third one is that red line that says no more than this. You're forcing that. So what we did was we actually did this. So this is the most important part, which is the on-demand, just-in-time disclosure interface. And this is how it works. So I start with nothing displayed. I've got some metadata that help me think about this. If I feel like I need more information, you would click and you would get more information. So in this case, Junior was opened. If I still need more information, you would click and you would see even more, where you get to now full disclosure. So this is the process of a dynamic interface where you click to see more during the job when I need to see it. That's what you're doing, right? So again, status quo is everything. My approach is here's nothing. You can click to see different things, and you can make your decision. And then based on what I've looked at, you're going to measure the risk. What is that orange? That orange is when I hover over. So based on what I've looked at, that's the risk. Blue is what I've seen so far. Orange occurs when I'm actually mousing over this. It tells you that if I click, I'm going to see that much more. I get to decide after I look at this whether I want to click or not. If it's worth it, I'm going to click. If it's not, I'm not going to click. And then on top of that, so there's a little math in terms of how you do the measurement, but I'm going to not talk about that detail, right? So then finally, there's that red line. And so I can make a decision during my job whether I'm going to click open or not. And I'm being told that I can only go up to red. So that's the last part of that interface. So we had 3 hypotheses to look at the effectiveness of each of the design. We did a user study. And I'm going to skip over all of these, where we tested our hypothesis. So the main results is this. What we found, and this is what I shared, So the first two design is 100 to 7.8. It went down that much. And the other graph that says no difference, that's the quality of our decision. So you can see that the quality of the decision is pretty much identical, whereas what I've looked at is when you measure it is quite low. So this actually tells you that on-demand interface is very effective in giving you the privacy enhancement without affecting the utility. The other result that I'm going to highlight is the fact that actually if you go too low, if that budget is too low, then yes, my quality of results. So it went down to 19.5%. So the quality of my results just suffered because I didn't have enough budget to work with. And that's what you have to remember is that's why there's no free lunch. So when you're doing a system like this, you need to have a budget that is sufficiently big so I can do my job. We also measured completion time, which for all of these different conditions, we didn't find a lot of differences. And then we also had an expert study. So we actually surveyed experts who do record linkage with full access most of the time. And they answered some questions. They used our interface, which, here's a quote. Once I got used to the coding, allowing partial disclosure helped in decision making. What you're seeing here is evidence that actually, when I'm trying to help with privacy, it also helps with the decision. Why? Because you're not getting raw data. You're getting actually processed data and information that is good to support your decision. So that actually improves the quality of the decision. We had one expert who actually had experience using that encryption method. And he had said, I never know how well the hashing worked or how accurate it is. It would be helpful to use this method to spot check a random sample to know that your hashing methods are working. So here's the results, and then some closing thoughts. People talk about threat models in this research. What I would like to say is this privacy-enhanced system, it's a threat model of an insider threat. So yes, I have approval. I have approval for this purpose. If I'm in there doing other things, that's a problem, right? So what these systems do, because it's a surveillance camera, it checks what I'm doing. It checks what the data science is doing. So these systems help with protecting against insider threats. And this is the team. So I'm a data scientist. Eric is a Hye researcher. Kason is, by the way, a lawyer. So what we've shown is that this way of doing partial disclosure just in time. It actually meets the legal definition of minimum disclosure. Those are requirements in GDPR and HIPAA. None of them say no access to data because you can't do all of the laws say give the minimum necessary, except nobody knows what that is. And there are no computers that enforce minimum necessary. And so the minimum necessary with the current computer systems is everything. And that is the problem. So if you have Hye researchers who build systems that can actually sort of help implement the minimum necessary legal standard, then you can get a lot further in terms of getting benefit from data while still enhancing privacy. Thank you.
Any questions from the audience? Okay, I have a few questions. If that's
okay.
Right. I was just wondering if you could talk a little bit about the decision making of the end user part of your paper. So, like, if I'm a user and I want to see more, what's stopping me from not wanting to just always click and see more? I know, like, you can design the study to, like, say, like, you only stop once you reach this point, but, like, it's putting a lot of burden on the researcher to hold back. So, like, do you have any thoughts on that?
So the thing is, when you're doing this record linkage task, I would say the most difficult pairs. This is usually, the way this works is you run lots of algorithms and you're not looking at 10,000 records. The algorithms take care of all the easy ones. So the ones that I'm looking at are actually the ones that even the computer doesn't know. And guess what? Humans don't know either. So I've had arguments with other data analytics people that go, it's not like humans know any better than computers. We might as well just guess. But when it comes down to it, when you have humans making judgment and decision, they can be held responsible. They can take into account the context of which you're doing the record linkage for. And so when you're actually in this setting and you think about the percentage of cells you're looking at, it is really, really tiny. You just have to keep that in mind. And the most important thing here to answer your question is I am not allowed to go query someone. So if you had a computer system like this and I was malicious and I wanted to find out if a friend of mine had HIV, it's not like what I can do is go in and query the system. What's happening is I am using automatic algorithms. It's linking whatever it can, and it's spitting out things that it cannot. So I am limited to looking at what it was confusing. in there is usually not the one malicious thing that I wanted to look for. So let's keep that in mind. The other part of this is, yes, we have a hard limit. So this is another thing. When you start to measure the risk, you can actually have a conversation. So I've done this, and I've actually done this research with IRB. We've talked to IRB people. And the way this is supposed to work is you go to IRB and you go, I'm doing this record linkage. Given my understanding of the quality of the data, I need 20%. IRB looks at it. I don't know how much they're going to be able to make that judgment, but they say yes. I do my best. I need more. I go back to the IRB. I said, I tried my best. Here's what I need more. And you can request. So you can have an iterative conversation and come to sort of an agreement as to the risk that you have to do, so you can balance that risk and utility.
Okay, well, thank you. Is there any more questions? Okay.
Yeah, so Dan Cosley, still from Cornell and NSF. So one of the things, I actually really appreciate that you're looking to sort of scope the tasks, right? Because often we don't scope the tasks. But often you're going to have a big data set. You're not going to know what tasks you're going to want to do with it in the future, right? And and so companies will use this as an argument to harvest and keep everything. Let's set that aside, and let's say that you're trying to use this method across a set of analysts, or over time, or across a set of tasks. Can you scale up some of or adapt some of the privacy cost computations that you're doing to sort of account for these kind of more complicated scenarios where you're sort of wringing data out of a data set over time?
So the current math behind how I measure the risk is actually not part of the Hye research, because with the limited number of pages, I couldn't. What I did was we did the math. That the most important part of the math is what you count as the denominator, in terms of, because it turns out to be a percentage. So from what I hear your question to be, if you have a more complex setting, your denominator changes. Currently, what's in the numerator is the kinds of things that you're looking at and how unique it is. So it actually measures the identifiability risk and not just at this general percentage of cells. So you can do the math in such a way that you take into account the right denominator, which is actually really important. Hopefully this answers your question, or some part of it.
Okay, let's thank the speaker one more time. Thank you.